Okay, so today we're going to talk about two skills and how to put those two skills together to answer questions on the GED. So today our two skills are when we deal with fractions using the bow tie method of how to deal with fractions, plus FOIL, which is adding and subtracting binomials. And our goal is at the end of this lesson to answer a question like this or to know how to handle it on the GED test, because this is difficult. There are 3 levels of depth of knowledge questions on the GED. There's level 1, which is usually one step, or it's pretty accessible. I'm not going to say the word easiest, but it's the most accessible. Level 2 is conjoining two things, or there's a twist in the question, or a couple different things. It'll be a geometry question, but it really has to do with algebra. That's a level 2. And level 3 is the toughest, taking algebra or geometry to its toughest part, or to its toughest degree. And that would be a question like this. So dealing with fractions is at this level. Doing FOIL is this level. And then if we add those two things together, we can answer a question like this. Okay, so if we were talking about adding and subtracting fractions, or that's Latin for when kids started to hate math in 3rd grade, they used to teach adding, well, they still, who knows, what they teach about adding and subtracting fractions is that we have to get the lowest common denominator, and the denominator is the bottom numbers, which means they have to match, and they want it to match in the lowest possible way first before we can do anything. So we take 3 and 5, and we start multiplying them out, or doing the parts, either factoring or doing multiples. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and we found our match, which means we have to change the bottom numbers to make them 15. When if you change the bottom, you got to change the top, so you got to do that math. You got to multiply that by 3, and you got to multiply that by 3, and suddenly you get, oops, did I lose mine? Where'd my share go? There it is. Sorry. And now I can add those two things together and get 13 over 15. We don't do it that way. Sorry about all the clicking, but I just want to make all that confusion disappear. This is how we do it. Multiply across the bottom. This is the bow tie method. So everything in blue is the method we're going to teach. Multiply across the bottom. Then multiply that way. Then elevate the sign. And then multiply that way.
Mm-hmm. I'll understand that a little better.
And then add those together and put them there. Now, the answer is technically right. It may need to be adjusted, but that other way may need to be adjusted too. So we just get to it. The answer is technically right. It may not be in its best terms. So reduce, maybe we have to reduce it. Improper fraction, do we have to change it around to a mixed number or whatever? Maybe. We'll learn that stuff later. The answer is technically right.
Okay, so when you
now we're going to practice this.
Technically.
Okay, so we're going to do the top 1/2 time plus 2/5, and we're going to use that bow tie method. Okay, so it's multiply across the bottom, then multiply that way, put that number up there, lift the sign up, multiply that way, whatever the answer it is, drop it in there. Now, you pause the video and then use that same method on these two and see how quickly we can get these right. All right, so we did our method and our example, and let's see how we do here. Multiply across the bottom, multiply that way, raise the sign, multiply that way. There we go. Now, I'm using examples that don't need to be reduced. So I'm taking the simplest way. There are times when we're going to have to reduce the answer. However, the answer is correct. Even if it's not reduced, it's technically right. We just have to get it to its better form. We just don't want to teach that right now. We'll teach that stuff later. And there we go. So I'm going to put up some more examples, And when I make this video, whenever that is, maybe I'll put some music in the background. Okay, these are 4 examples. If you're a visual person, this is the shape that you want to do. It kind of looks like a pitchfork, or they say bow tie, which is fine. So I'm going to pause the video, give these 4 a shot, and I'm betting on you. I'll bet you get them all right. Okay, so that is our visual key for what we're doing. And let's see how this goes. Across, back up that way, lift that sign up, back up that way. I forgot to do the arrow. 9. Doesn't have to be reduced, but that's not our skill. Right now, the skill we're focusing on is adding fractions. Cross, back up, lift the sign, back up that way, and there we go. Now this next one's going to have to get reduced, but that's okay. Like I said, we're not worried about that skill right now. We'll get that skill later. And lift the sign, do that, add those 2 together, plop them together. Now 21, 27s, 3 would go into both, but again, like I said, that's not the skill we're focusing in on right now. We're putting tools in our toolbox. That'd be 7/9, and we'll get to that stuff later. So here we go, going across the bottom, back up at the top, and there we go. Do we feel comfortable with this? How do we feel?
Yeah, I do. Look a lot better.
So we can look at adding and subtracting fractions and go, there's a method, and I know that method, and I'm going to practice that method once in a while, but I am not going to attach the burdens of all those other skills on this one skill. Now, the odds of them asking a question super directly about 2 fractions adding together are pretty low. Now, it may happen. That'd be great if it did, because we just crushed it. What they will do, though, is ask questions that involve this, but also stack algebra and other steps on top of it. So next, we're going to quickly do subtracting, how to subtract fractions. And we actually already know how to do it. Okay, so I'm using the same fractions. So if you were doing this on a piece of paper, almost all of your work is already done, because it's the same steps. Adding and subtracting are brothers. They just pull in different directions. We multiply across the bottom, and it's going to be 10. We multiply across up that way, and that's still 4. The only difference is elevating that sign. And then we multiply that way. 4 minus 5 would be -1. And we get to use our calculator for an awful lot of this stuff.
We don't subtract until we get finished with the whole operation.
Yep, this is the only difference. So if you did this by hand and you look at all the work you've done, all the multiplying is still the same numbers, except for that last step. So
yeah,
that's
but why are you multiplying when you said subtracting is still okay.
This is the only difference, is when we elevate the sign.
Oh.
So you learn one, you learn the other.
Why is it -1?
Because 4 minus 5 is -1.
Oh, 4 minus 5. Okay. Yep. Okay, I got you. Okay.
And sometimes we get a negative answer, or if we get a fraction, or if we get a decimal as an answer, we get apprehensive because it doesn't feel right. Well, if Isaac was in class, he would say, negative numbers are numbers too. Now this would need to be reduced, and it would come, because 3 goes into both, and that would be 1/9. But we're not doing that right now. That's not our skill. Our skill is getting to a technically correct answer. So the difference between adding and subtracting fractions, when you use this awesome bow tie method, which is free of charge, the only difference between adding and subtracting is when you lift that sign. 3 minus 8 would be -5. And there we go. Not too bad.
No, I got it now.
Awesome. Now, I'm going to throw on multiplying and dividing fractions really quick, although that isn't the thing that we're connecting to get to that other problem we started with. But we're here, and we might as well talk about it. So 2/3 times 1/2. Multiplying fractions is a drag race. That we have that lane and that lane. Like in the end of Rebel Without a Cause, when James Dean character races against, I forget the other dude that challenges into a drag race, and they do a chicky run, they drive off the hill and whatever, and that kid dies. Great movie. That's exactly what multiplying fractions is. It's a drag race. So you just multiply across top, multiply across the bottom, and yes, this fraction needs to be reduced, but that's no big deal. That's not what we're doing right now. So I'm going to put up some quick practice ones. All right, so we have 4 examples. Like I said, this isn't exactly what we were connecting for our skills to answer that one question where we work with FOIL, but we're here, so we might as well talk fractions. So if you want to pause the video real quick and give this a try. Okay, maybe you started the video again. Here we go. Across top, across the bottom, it's a series of drag races. And this one, they're both even numbers, so we can cut them in half, and we reduced them. So that is multiplying fractions. And while we're talking about multiplying fractions, let's talk about multiplying fractions and whole numbers. A lot of time, actually every time, I don't know why they do this, drives me crazy that they will draw the whole number and the fraction as the same size. They're not. They shouldn't do that. So this is terrible because it should go like this, because every number is a fraction. You can't hate fractions because all numbers are fractions. That means you hate all numbers. Whole numbers have a ghost 1 underneath it. So it's just like hating one kind of people, then you hate everybody because we're all the same. If you have $7 in your pocket, and even if it's a 5 and 2 ones, you have the value of 7 $1 bills. So everything's a fraction. So as soon as if we don't draw it like this, put the top number up here, at least have it even. Even if you're not going to draw the fraction with the ghost 1 underneath, at least make those the numerators. That means number. These are the denominators, which means the denomination of the thing that we're talking about. Who cares what those terms mean? The point is the top number defines the number. The top value defines the number. Who cares about it? It's drag race time. So we get 4/3. This is an improper fraction, which we would later on convert into a mixed number. But that's not the skill we're talking about. The skill we're talking about is this, that when you multiply fractions and whole numbers, it's a whole lot easier than it looks.
So if you have a question like this on the test, you have to do the whole thing like that. You have to add this fraction with the whole number first, and then make it into another fraction.
Well, you just realize that every number, like if we did, let's do another example real quick. If we did 3/4 times, I don't know. Well, let me pick a better example. Let's do 1/5 times 3. Now that's how it'll look. They'll do the fractions the same size as the whole number. But it's not 3, it's 3/1, because all whole numbers are fractions. So we should make things the same size.
So it'd be 3/5.
No, it'd be 3/1. Yeah, oh, the answer would be 3/5. You work fast. Every single time I dress something up, you already know the answer.
Jeff, I'm so happy that I'm learning this. I never, ever, I thought like I was the dumbest person ever to learn this kind of stuff. Like nobody could ever teach me because I didn't understand it.
Let's blame the teachers. I'm sure, and let's blame the curriculum because they were teaching all, like I said before, they were making fractions a convoluted task, and they didn't have to. If we were juggling chainsaws while we were making scrambled eggs, and then we're judged on how well we make our scrambled eggs while we're juggling chainsaws, we're not going to make good scrambled eggs. But just make each skill its own thing, and then assess that skill, we feel more confident, and we feel better. So now we're going to do divide and fractions. And divide and fractions is great, because you don't have to do it. So dividing fractions, like I said, nobody ever actually has to divide fractions, because we look at dividing fractions and we think, oh man, that makes me sad. I don't want to divide, I want to drag race. And math says you can. Keep change flip. Keep the first fraction the way it is. Change the sign to multiplying, and then flip this thing upside down, and we get to drag race again. And that becomes 1 1/3. All right, so we're going to go to FOIL now, and talk about algebra. So this is where we do an abrupt change. We just nailed down 4 great skills.
Yeah, awesome.
And now we're gonna move over to algebra just for a second. So this isn't a complete introduction to algebra, but or whatever, but we're going to do a very brief introduction to algebra. Algebra is when we mix numbers and letters together. It is a legitimate place of apprehension and anxiety when it comes to math, because we were taught a different way of math growing up. We were taught something like this. All the known things would be on one side, and then the unknown thing would be on the other, or they would stack it like this, and all the stuff we would know, I know 5, I know 7, they're 5 and 7, I'm familiar. I would add them together and put the answer down here. But once they start mixing up the unknowns and the knowns and write it like this, 5 plus something equals 12, well, and then they took away the something and said, let's just call it x, because x is a number, it's the missing ingredient, it's the thing, it's the number we don't know. Well, what do? Well, we prefer the unknown thing to be by itself. In other words, we got to play country music and get all our X's alone, because we're going to play some twangy music and She Broke My Heart and all that stuff. I wish she was alone. So to get everything on the X side away from it, in other words, isolating the variable, we got to get rid of this 5. So 5, it's time to go. So 5 is positive 5. It's just sitting there being 5. Well, it's time for you to go. And the only way for it to go is subtract 5. That is the exact way to remove 5 from that situation. But we want to be equal and fair, so we got to do it on the other side. This cancels out. It's like somebody hands you $5 and then takes $5. You end up breaking even. And now the X comes on down by itself, and we get to do honest to God math. Just like we used to do here, we do it on this side, and we isolate the variable and find out that X equals 7. So we go back to our original problem. We get rid of the 3 by doing the opposite. Minus 3, well, we add 3, but we got to do it on both sides. These cancel out, X slides on down, and we do real life math right here. So that's our super fast introduction to algebra. Now we're going to jump way at the end of algebra to something called FOIL. Okay, now we're jumping to the end of algebra. We just introduced the beginning of algebra. So know what I'm doing right here is going from chapter 1 to chapter 17 of the algebra book. But that's okay. If you're watching this and you kind of feel comfortable with what we've done so far, we have to stretch, and this is our stretch. So if we're going to multiply these two things, x plus 3 and x, we don't know what x is, and x plus 2, and we don't know what x is, there is a method. Now, why do we do this? Who knows? But it's going to be a question and a skill that's going to be on the GED math test. And it could just be on its own. It will not be on the formula sheet. There's 2 things that are really important that aren't on the formula sheet: distributive property and this multiplying binomials is what it's called. So this is what we do. This is called FOIL. So we're going to multiply things as FOIL tells us. And I always draw a little nose on the I and the O because there's a final little cleanup step. Now, how do we multiply these things? First means the first things get multiplied. X times x is x to the second power. X plus x would be 2x. X times x, and there's tons of multiplication in algebra, is x squared. And what you want to think of it is just like 3 times 3 is 9. 3 to the second power is 3 times 3 equals 9. So it's kind of like 2 x's are stacked on top of each other Like if you cut out 2 paper X's and you stacked them and you didn't know how many X's there were just by looking down, that little number tells you there's 2. So as soon as we find out what X is, we're going to multiply them. So if X is 7, oh, okay, cool, X is 7. So we check our number. Oh, there's 2 of them. 7 times 7 is 49. So that becomes that. So we just did it, and it's going to be very predictable. How much work was that? None, really. Next is Scotch tape time. The outside ones are going to get multiplied. That means X and positive 2. Well, we just Scotch tape them together, and they become positive 2X. How much math is that? None. We just tape them together, and they sit there for a second. Then we do the inside ones, and that is positive 3 and X. So that is Scotch tape time, positive 3X. And then L stands for last, and that's multiplying actual numbers. So we're back to actual math, is 3 times 2, and that's positive 6. Now we have one last step to do, because these two are from the same family, and we got to get them together. Analogy we always use is like, it's wedding reception time, and the kids are all running around. We got to get all the families at the same table. So we got to get them seated together and bring them together. So, here's the grandparents or whatever. Here are the parents, and the 3 kids are running around. I'm like, we got to get that X family together. Come on now. So 2 plus 3, or positive 2 plus 3, turns into 5. And now the X family's sitting together. And then everything else sort of slides on down. Plus 6 comes on down. The X2 family comes on down. And that's our answer. That's called a quadratic equation or a quadratic expression. Who cares what it's called? We've done all our work. When are we done? When all the families are together. The X2 family's together, the regular old X family is together, and the regular old number family is together. That is FOIL. So I'm going to put some examples on here, and we're going to practice doing that just to get it square. Okay, so the equation on the left, or the expression on the left, is the same one. I didn't mean to, but it's the same one we just did on the last slide. So we're going to run through that as a sample, and the one on the right is new. Now notice that there is a minus here. So in a lot of that math, we use your calculator. Be careful and use your calculator when we don't want to trip over something small. So pause the video. What you had for the previous example written down is going to be the same thing here, but we could practice the mechanics of it, and then this one will be new. So give it a pause. All right, so we're going to run through the left side, and it should be kind of familiar. First, we do firsts. X times X is just X squared, or X to the second power. Those two, square and second power, mean the same thing.
That's right.
Outside is Scotch tape. Outside and inside is Scotch tape. So X times positive 2 is just Scotch taping together. It's positive 2X.
Positive 2X.
Inside is these two. Positive 3 times X is positive 3X. Just Scotch taping together. And then last is actual math. 3 times 2 is positive 6. And then we got to bring those two together. We got to get the families together. 2 plus 3 is 5. That's the X family. The number only family comes on down, and the X2 family comes on down, and we're done. Because it's forks, knives, and spoons. Everything's in the right slot. So now we're going to try the same thing on the other side. First is those two, and that's always going to be that. It's pretty obvious. X to the second power. X times X is X squared. X plus X is 2X. But X times X is X to the second power. Outside is Scotch tape. So the outside one is positive 4 times X. So we just write them next to each other. Inside is the inside numbers. Negative 2 times X. Scotch tape them together.
It's negative 2X.
Yep. And then the last one is actual math. Negative 2, because the sign travels with it. Negative 2 times positive 4. In our calculator, we want to use that, is negative 8. Then we got to get the X family together, which is just 4 minus 2 and we get 2x, everything all comes on down.
And there's your answer.
Can I ask you a question?
Sure thing.
So you're taking the things that are inside of the parentheses and you're multiplying like x times x. I got that for the x squared.
Mm-hmm.
And then then you take the -2 times.
We do FOIL. So the F stands for firsts.
Mm-hmm.
So the first thing are these two.
Okay.
And then we do the outside ones for O, which is this one and this one. And we just scotch tape them together.
Okay.
So it becomes positive 4x. X times positive 4 is
So
just
4 times x and then the 2 times x also, or
no, the
right?
inside one is this and this.
Oh, okay.
Scotch tape them together. Because we can't multiply them because we don't know what x is. So we just put them together. And then L stands for last, which is these two. And -2 times positive 4 is -8. And then we have to join the families together. We have to, when we have multinomial polynomials, we got to get all of the families together, and we got to get that x family together. So we take positive 4 minus 2. So 4 minus 2 is positive 2, and that's the x family. Then the number only family settles in, and then the x2 family's in, and now we can start this wedding reception because all the families are in the right.
When you get to the GED test, something like this would just be showing you, or it would say, compute this to its, what would the question even look like? That's what I'm curious about.
It would look like this.
Yeah, and it would say to do what?
It would say solve or simplify.
Solve.
It would say simplify. It can't say solve because there's no equal sign. If there's equal sign,
so it would say simplify.
This is simplify.
And that's what you have at the very bottom is the simplified equation. Okay.
Yep. And then please.
Sorry, I'm just making you back up a little because I know Claude just came in, and I thought, well, maybe he also wants to know what the FOIL stands for and what you're doing.
So this is, please excuse my dear and Sal, the order of operations. This is the last chapter of math that we cover. This is like for algebra. This is as far down the road as algebra gets. There is one more step of the quadratic equation and the quadratic formula where we deal with this. We don't give that a ton of attention because it's only 1 or 2 questions, and it is the hardest thing that is on the GED test, without a doubt. So we can touch on that, but we got to build up to it. So the furthest we go, if we were to run around the playground that is algebra, is this. Know this, and then don't know that other extra thing, the quadratic equation, you'll still pass. So we'll get to that. We'll touch that someday. And it's actually not that hard, but man, is it intimidating looking. So, but this is a skill that's going to travel all over the test. And the first step of order of operations is to get rid of parentheses. And this is the most complicated way they'll ask, is by multiplying binomial pairs. And this is not on the formula sheet. We got to walk in knowing it. Okay, so I'm going to do one last one, and we'll do it together. Okay, so this is what we call a summative assessment. A summative assessment it does not test what you know. It tests the value or the effectiveness of the teaching that we've done in this video. So if you can pause the video and look at your notes and go, I can get this into some sort of, it looks like this at the bottom, this sort of thing. If you can do that on your own, pause it right now and do it, then this video has been effective. If not, I need to know what part we need to go over. So it is on me. Okay, so that's what a summative assessment is. It judges me, not you. So pause video and give this a shot. Thank you for unpausing the video. Now we're going to do it together. First means these two. It'll always look like that. There will be some sort of x squared. and we're done.
Good so far.
Is that math? Not really. It's not work.
Just
We scotch tape the middle. The middle gets
Mhm.
scotch taped together. So the outside ones, x times +4, scotch tape them together. That's not math. That's arts and crafts. I stands for inside. That's
inside.
these two.
Mhm.
We don't know what x is, so you can't multiply it by 3, so just scotch tape them together for now. Last are these two, and that's actual math. So 3 times 4 is 12. We got our one last step. We got to get the families together. X2 family, they're already set up. Number only family, they're all together. But these kids are running around. We got to get them with their parents. We got to join these two together. So when we join them together, 4, +4, plus 3
Mhm.
is 7.
Mhm. Bring that 12.
And that's it. So that is how to do multiplying binomial pairs.
Bring that 12 right there.
So in the beginning of this lesson, we talked about how using the skill of adding and subtracting fractions using the bow tie method will help us answer one of the most difficult questions on the GED. That GED will not likely give a straightforward adding and subtracting fractions question. And if they do, it would be a -2/3 plus 5 1/3 or something like that. They would add other stuff onto it, which is fine, and we would handle it. But they don't linger there for very long because it's too elementary. So we need to learn how to do fractions the most efficient way possible, which is just like we did earlier in the video. We go across the bottom, multiply, cross top, raise that thing like we talked about, add those two things together and get the answer. This is the kind of question we showed at the beginning of this lesson, saying that skill above will help us answer this question. We'll get to this question in the GED, see that word simplify, and go, oh, crap. That is complicated looking. And of course it is. It is. Why not? It's math. And like I said, this is the furthest down the road we'll ever get on knowing math. There is one step further, and we can know that for fun, but it's not necessary to pass the test. So what do? First of all, don't panic. We look at it and we go, we're adding fractions. Yeah, they're complicated fractions, but people are allowed to be complicated. So we take our steps, multiply across the bottom. And as soon as we see that that's the first step, using that method of adding and subtracting fractions, all we realize is, oh my gosh, it's FOIL. That's what we're doing. We're multiplying binomials. And as I step through this, tell me where the math is that's difficult that you can't do. Because there's going to be 4 choices to pick for these 4 fractions. And they're going to be convoluted and crazy looking. But show me the part of FOIL where it's difficult math, because I know you can do it. First is x times x. X times x is x squared, or x to the second power. That's just knowing exponents, and we can get to know that and get to know it well. O is scotch tape. It's outside. X times +2, we scotch tape them together and get +2x. I is inside. That's more scotch tape. It's arts and crafts. It's not math. Tape +4 to x and just write them next to each other. L is actual math, and I know we can do 4 times 2. It's +8. We have our last step of getting the families together, the nomials. We got all our nomials together, and it becomes x squared plus 6x plus 8. And then you look at the 4 choices, and we know how GED writes these questions. 2 of the fractions and choices will have what's called a quadratic expression at the bottom of the fraction. 2 of them will merely add x plus 4 and x plus 2. And just by looking at that and knowing what multiplying binomial pairs does, we know those can't be true. So we could look at that. What do we do during the test then? What's the best test strategy? Figure out that either C or D is right, hit the flag button. You got to choose one. Choose C or D, one or the other. Go with God, take a pick. It's 50-50, it's a coin flip. But when you hit the flag button, you get to come back to this question at the end. And if you, just like Family Feud, in the second part of Family Feud, if you say pass, they come back to the question if there's time. And then you could finish doing the rest. And you could lock in by doing a FOIL that way, raising that sign, and a FOIL that way, and then just add those two things together, and you'd figure out which one of these on top is right. Is that a lot of work? Absolutely. But by knowing this skill, because of this skill, you can get to 50-50 on probably the hardest thing on the algebra section of the GED test and feel confident. So this is an absolute win. I hope that assessment worked well for you. I'm going to put up on this video a series of actual GED questions that involve binomial pair fractions, and that's where you practice FOIL. And by the way, getting more difficult questions right on the GED gets you more points. They're not worth the same. So a number line question and a question like that are not worth the same. If you want to pass, you got to get difficult questions right.